going to talk about precipitation reactions when you take two solutions, mix them together, and a new solid is formed. So you start out with two reactants that are aqueous, and you end up with either two products that are aqueous or a product that is a solid and one that is aqueous. In order to figure out what's solid and what is aqueous, you have to have some idea of the solubility rules. And we're going to make this really easy for the time being and even simpler than this list of solubility rules. Okay, so you need to know what is soluble. And soluble means it dissolves in an aqueous solution, and we call that aqueous. All group 1 cations, anything that is bonded to a group 1 cation or the ammonium polyatomic ion is soluble, no exceptions. All nitrates, acetates, and chlorates are soluble. Everything else is a sort of. So read these, but know that all statements are pretty rare in chemistry, and you can take these to the bank. These will be soluble. If something is insoluble, that means a new solid has formed, and you would put S next to it when you were writing your complete equation. It says using the solubility rules, predict what will happen when the following pairs of solutions are mixed. In this double replacement reaction, the cations will change places, so we will have potassium chloride, written properly, do not move subscripts, and we would have barium nitrate. Balanced like this. This is a group 1 cation, so it is aqueous. This is a compound containing a nitrate, so it is aqueous. And so we would say there is no reaction here because these all break up in water. When we put together in a beaker sodium sulfate and lead 2 nitrate, the cations switch places to make sodium nitrate and lead sulfate. And it would be balanced like this. This is a double always. This is a group 1 cation and a nitrate. It is soluble. This is a lead compound. And it says here all sulfates are soluble except those that have lead as a cation. So this is insoluble, and a new solid is formed. Kind of a weird arrow here. Potassium hydroxide and lead 3 nitrate will exchange cations. So you would have potassium nitrate and iron 3 hydroxide. This would be aqueous by virtue of the group 1 cation and the nitrate, and this would be a solid because most hydroxides are insoluble. I'm going to leave writing a net ionic equation for another day. It seems to be a bugaboo for folks, and it will require its own lecture. Now we're going to talk about some stoichiometry problems when we're talking about double replacement reaction. A lot of times you will need to not only determine how much of what new solid is formed, but how much of a new solid is formed. Here's an example of that type of problem. It says when aqueous solutions of sodium sulfate and lead 2 nitrate are added together, a precipitate forms. The precipitate is lead sulfide. Calculate the mass of lead sulfate formed when 1.25 liters of the 0.05 molar lead 2 nitrate and 2 liters of the 0.025 molar sodium sulfate are formed together. Let's write a balanced equation from the reactants. Now, in order to determine how much lead two sulfate is formed, we have to determine what is controlling the reaction, what is the limiting reactant. And we can find the limiting reactant only by using moles or particles, not molarity. So I do recall that if molarity is moles per liter, then moles should be molarity times liters. So I will find the number of moles of Na2SO4 by using its molarity times its volume, and that gives me 0.0500 moles. The number of moles of lead nitrate equal to its molarity times its volume. It's 0.0625 moles. All right, we would like to know how many grams of lead 2 sulfate are made, and that will be the least number of grams, and that will determine the limiting reactant as well. So we start out with 0.0500 moles of sodium sulfate. According to our stoichiometry, 1 mole of sodium sulfate is equal to 1 mole of lead sulfate. 1 mole of lead sulfate has a molar mass of 303 grams, and that gives us 15.2 grams of lead sulfate that can be made when we use up all the sodium sulfate. The number of grams of lead 2 sulfate equal to the number of moles of lead 2 nitrate can be also determined using stoichiometry. And that yields 18.9 grams of lead sulfate. The reaction stops when we run out of the limiting reactant, Na2SO4, so 15.2 grams of lead sulfate are formed. What mass of silver chloride are formed when 57 mLs of 0.125 molar NaCl is mixed with 28.7 mLs of 0.350 molar AgNO3? So our equation would be solutions of sodium chloride and silver nitrate are mixed together, and we are left with sodium nitrate and silver chloride, and the silver chloride precipitates out. Once again, we need to figure out which one of these two limits, because that controls the amount of the new solid that is formed. So the number of moles of NaCl equal to its molarity times its volume in liters is 0.00173 moles. The number of moles of silver nitrate is 0.350 moles times its volume, 0.0287, and that is 0.01. So we would like to know the number of grams of silver chloride that are made by each one of them, so we can determine the limiting reactant. Everything has a 1-to-1 stoichiometry. So we made 1.02 grams of silver chloride from the NaCl. silver nitrate. The reaction stops when the limiting reactant runs out, so we can make 1.02 grams of silver chloride in this reaction.